Now, a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 12 inches by 20 inches. By cutting out equal squares of side X at each corner and then folding up the sides as in the figure. We're going to express the volume V of the box as a function of X. So the first thing we need to do is define the height, the length, and the width. Well, the height is going to be the value of X. So what is the length? And then what is the width? So we need to use our dimensions from our figure. So if we want to find the length here, we have an X and an X that we have to remove from the 20. So this is going to be, since we're going to subtract an X here and subtract an X here, then the length is going to be 20 minus 2x. So the length is 20 minus 2x. Now for the width, very similar. We have an X here and an X here. So we need to subtract an X here and subtract an X here. So that becomes 12 minus 2x. So now that we have the height and length and the width, we can then express the volume of the box as a function of X. Well, first and foremost, what do we know is the formula for the volume? Well, that is length times your width times your height. So, since we want to make this into a function of X, so it's going to be V of X, which is equal to the length, which is 20 minus 2x, times the width, which is 12 minus 2x, and then times the height, which is x. So let's multiply that out. So we have V of x, which is equal to 20 times 12, which is 240. On the outside, we have minus 40x. On the inside, we have minus 24x. And then plus 4x squared. And then we'll distribute that x. So V of x, we can rewrite this. So let's see here. We have 4x squared minus 64x plus 240. And then we need to distribute that x. So therefore, the volume as a function of x is going to be 4x cubed minus 64x squared plus 240x. Now, if we wanted to go further to find the domain of the function, we need to take into consideration both the length, and so the length has to be positive. That means it has to be greater than 0. And so if the length has to be greater than 0, well, the length is 20 minus 2x, which has to be greater than 0. If we solve for x, we get negative 2x, which is greater than negative 20. If we divide both sides by negative 2, we need to flip the inequality. So x has to be less than 10. Now we also know that the width is greater than 0. And so if we take 12 minus 2x and set that to be greater than 0, we get negative 2x, which is greater than negative 12. If we divide by negative 2, that means we need to flip the inequality. So x must be less than 6. So here it says less than 10, but it's got to be less than 6. So what does that tell us about the domain? meaning what are the values of x that we can choose from? Well, we know that x has to be in between two numbers. Well, we know it has to be greater than 0, and it has to be less than 6. So therefore, x has to be in between 0 and 6. Or in interval notation, we'd have 0 to 6.